5 slides in 5 minutes. Here we go. Alright guys, this is my updated project roadmap. My entire goal with this project is I want to be able to quantify in-season travel stress and schedule congestion stress within the NBA. And I want to be able to find the correlation between some of those variables and in-game performance variables. What this is going to be able to do for organizations is it's going to be able to it's going to enable us to forecast the highest periods of stress within our season and guide decision making based off of that prediction and that relationship with in-game performance. I'm going to be looking at 3 main sources of data. There's going to be travel data, schedule data, and like I mentioned, performance data. And this is going to shift the way that major NBA organizations conceptualize travel and the stress that it imposes on their players, which is their most valuable commodity. And everyone wants to keep NBA players healthy and performing at the highest level because that's how you win championships. And this is going to enable NBA teams to do so. My data set is going to have 3 components to it. First is going to be schedule data. So I'm using the 2018-2019 season for the Cleveland Cavaliers. That includes who we play, what's the location, and how many days of rest are we on, which is what I'm going to call congestion. Then we're going to look at some travel data, which includes the distance traveled, the route that we took, time zones shifted, and what direction of travel we went to. Finally, I'm going to merge those 2 into one data set and call it stress. And then I'm going to take 3-point percentages for each game that was played, and I'm going to merge those into the stress data set to be able to quantify the relationship between stress and performance. My linear regression models are very simple. As I mentioned, I'm going to look at 3-point percentage for any given game and 5 different stress variables. The first stress variable is going to be very simple, location, which is home or away. So does the home field advantage really hold true, and how much does it matter? Model 2 is going to look at congestion. So do we have 3 days of rest, 2 days of rest, 1 day of rest? Is it a back-to-back? Are we playing Monday and Tuesday? That kind of thing. And then Model 3 is going to look at how many miles were traveled. Very simple. Does traveling more miles negatively impact our performance? And then Model 4's got direction of travel. So does it matter if we travel east versus west? Model 5 is going to look at the numbers of time zones. Did we gain an hour of time going to Milwaukee? Did we lose time going to LA? So that sort of thing is going to impact performance as well. And I'd like to look at the correlation or relationship there. I had to make some decisions here. The first decision I made was to switch from using a proprietary sort of metric called closing spread differential to measure performance. I think it's a little bit of a noisy metric, and it might benefit me to choose a simpler metric. So that's why I'm going with 3-point percentage. And then I'm also choosing to go simple with just using single predictor linear models versus something like an advanced regression analysis where I can have factors and multiple predictor variables. If you notice, all of my models only have 1 predictor variable. And that's also why I'm going to be using R squared to determine the amount of variation in the response variable, which is 3-point percentage. And I'm using that over something like the standard error of the estimate or adjusted R squared, again, because I only have 1 predictor in all of my models. So my project's very important, guys. This is a very near and dear topic for me, and this is a graph that outlines our season schedule and what our flight paths look like in any given season. And it looks like a 4-year-old drew on a piece of paper with a crayon. It's chaos, and the NBA season is truly chaos. And I'd like to quantify just how chaotic that season really is, because there's been a lot of literature to suggest that the chaos does really take a toll on NBA basketball players, and as an NBA organization, our most important commodity is our players, and we don't do well unless our players are first off healthy and performing at their optimal level. So this will hopefully shine some light on how we're able to make better decisions and better manage in-season travel stress. Thank you, and I'm looking forward to everybody's feedback, and I'll see you on the discussion boards.